All right, so let's look at these last couple of problems here too. So this one we have a right circular cylinder. Uh, we want to we want to minimize the amount of material that we use. So that surface area that we're talking about, we want to minimize. And we need to have the can, it has to hold 12 ounces of soda. So this is why your soda cans are shaped the way they are. They're using the minimal amount of material. So if we look at this, I don't know if the diagram really helps you here. The volume has to be 12 fluid ounces. And volume for a cylinder would be the area of the base times the height. And we know the volume. It has to hold 12 ounces, and each ounce has 1.80469 cubic inches of material there. So this gives me 21.65628. Hold on to lots of decimal places till I come up with my answer. And then this is pi r squared h. Right. This is my, that's really awful looking, isn't it? This is my secondary equation here. Okay, that I'm going to solve for either r squared or r or h. And I'll have to figure out which one would be easier to solve for. So let's look at the surface area for this can. So a can of soda is going to need sides, and it's going to need a lid and a bottom. So the surface area, I have two circles, so pi r squared, that's the top and the bottom. And then I also have the, around the can there, if I stretch the sides of the can out and make them into a rectangle, the length of the rectangle is the circumference. Right? And then the height of the rectangle, this side here, is going to be the height of the can, which we call h. So I have 2 pi r h is the size of the can there, if you want to think of it that way. So if you look at this equation, if I can get rid of this h and make it into some kind of r, I'm going to have an equation with all r's. So that's what we're going to do. Let's go back over to the secondary equation here, and let's get rid of h by solving for h. So I'll have 21.65628 over pi r squared. So I'm going to take this and plug it into my surface area equation. Take out h, we'll replace it with what it's equal to. So 65628 over pi r squared. All right, now we can simplify this a little bit because I have to do the derivative. So I'm going to make the derivative as nice as I can. This pi will cancel with this pi. One of these r's cancels with one of those r's. So I have 2 times that 21. So that's going to give me a 43.31256. And then r in the bottom, I'm going to read up top and make it r to the negative 1. Great, now we're ready to take the derivative since I have all one variable here on the right-hand side. So the derivative of surface area, I'll just make it SA prime. 2 pi r squared would be 4 pi r. If I take the derivative of 43 and the r to the negative 1, I can change that and make it minus. So minus 43.31256 r to the negative 2. Okay, and then this is my derivative. Set the derivative equal to 0. So 4 pi r equals this 43 over r squared. We can cross multiply. I'm going to have an r times an r squared will give me an r cubed. And then if I divide by 4 pi, be careful. You've got to put 4 pi in parentheses when you type it in your calculator. We get 3.4467, and then the cube root is going to give me 1.511. This was measured in inches. Right? And if the radius is that, if I plug the radius back in here, I'll get a height of 3.019. And you can do that with your calculator there. All right, so then we get to decide what we want to do to come up with this. I did the second derivative test for this one, so let's try that one again, since we didn't do that since the first example. So my second derivative test, if I take the derivative of 4 pi r, it's going to give me 4 pi. And negative 2 times the negative 43 is going to give me 86 point something or other. R to the negative 3. And if I plug in my 1.511, well, 4 pi is always going to be positive. 86 over 1.511 cubed, that's going to be a positive number plus a positive number, so it's greater than 0. So then my justification would look like since SA is what I call the double prime, second derivative is positive at R equals 1.511. Let's see, surface area, SA is concave up. So being specific as to what the second derivative being positive means. Therefore, R equals 1.511 inches is a, concave up would be a minimum. All right, and we came up with the dimensions, we answered the questions that they asked.